Hey guys, I'm Srini and welcome to my channel Digital Srini on YouTube. In this video, I'm going to cover a topic that's heavily requested by our viewers of this channel. And this is basically classification of HAM10000 dataset into one of the 7 classes. And this video is dedicated to loading these images, whether you would like to work with Keras or PyTorch. You obviously have to focus on loading the dataset first. So I'm separating this from the actual classification video because this video by itself could be useful for you in loading other datasets that have very similar structure. Okay, now first let's understand what this dataset is all about. First of all, HAM10000 stands for Human Against Machine with 10,000 training images. So as you can imagine, this dataset has about 10,000 training images. And these are publicly available courtesy of Harvard database dataset. I'll leave a link to this in the description, and I'll also display the link in a minute on the screen. It contains 10,015 dermatoscopic images, basically the skin images showing the lesion. And it also contains a metadata file, right? I mean, you have all these images dumped into 2 folders. We'll look at the folder structure in a minute. And for each of this image, it actually tells you which class it belongs to. Now, how did they know what class it belongs to? I'll get to that in a second. And more than 50% of these are confirmed through histopathology. Okay, and the remaining 50%, it's either follow-up examination, or it's either expert consensus or confirmation by in vivo confocal microscopy. Okay, so there are basically 4 different methods. These are all confirmed, and each image is tagged with the appropriate metadata, which is contained in the CSV file. Now, even if you're working with any other type of data sets, you'll probably have very similar structure. All these images are probably dumped into a couple of folders or a single folder, and you have a JSON file or CSV file that tells exactly what each image name is, and then what other metadata that goes along with this name. So the technique here is we're going to use that name, find that file in a folder, load it. Okay, that's basically what we're trying to do. Okay, now if you open these images, they kind of look like these. These are all low resolution images, but it kind of gives you an idea of how these images look like. And each of this image, or it's tagged into one of these 7 classes. Okay. And we'll later on see that these classes are all not perfectly balanced, and I'll also try to include how to work with imbalanced data in the next video. So please stay tuned for the next video where we talk about classification of these. But these are the 7 classes we'd like to classify each of these image into, and it's not an easy task. Just by looking at this, if we get anything above 50-60% of accuracy, we are good, but it's up to you how you put together a nice model that gives you even higher accuracies, like 70, 80, 90%. Okay, let's stay focused on the dataset itself. Finally, where can you get more information about this? First of all, to download this, here is a link. I know watching this video, that's a difficult task, so I'll include the link. Please look at the description down below, and this is how the web page looks like. You can access the dataset from here. You can download it. It's an archive. It's a zip file that contains all these images. Again, we'll look at that in a minute. Now, here is a link that also provides you more information about this data set if you really want to know more about these images. And this is basically the information about this data. Okay, now let's jump onto the code and quickly have a look at what are these 2 ways, okay, to load this data set. Now, before, again, as usual, jumping into the code, let me show you the folder structure. I actually downloaded the zip file. When you unzip it, it actually, in this case, I placed everything into this folder called HAM10000. Okay, so when I go into this folder, you'll see that it has 2 subdirectories. Okay, and first one has 5,000 images. So instead of putting all 10,015 images in one folder or one directory, they actually placed the first 5,000 in this folder and the second one in part 2 folder. Okay, you can combine all of this into one if you want, or you can write code such a way that it just looks at these 2 folders for the file name. Okay, so it's these 2, and then the metadata here. So if I open this metadata file, Again, I'm using Notepad++ because I do not have Microsoft Office or anything on this system. You can see this is how the metadata looks like. Okay, if I go all the way down, there should be 10,015 of these. You see 10,016, first one being the header. Okay, so total 10,015 images. And the first one stands for lesion ID. Okay, this we're not going to use it. The second one is image ID. This is basically, if you look at this, and let's go back to this folder. So 24306, okay, is the image ID. In this case, 27419. If I actually go down, there should be 27419 somewhere. Okay, it's important. Let's go ahead and look at it. So 27419, 27413, we're almost there. There, 27419. That image, okay, has a lesion ID of this, and it's labeled as BKL. What's BKL again? Or BKL stands for benign keratosis-like lesions. Okay, so this one is classified as BKL, and using histopathology, and it came from someone with an age of 80 years, male, and from the scalp location. So there is a lot of metadata here. So if you just want to leverage all of this other metadata, in classifying, great. But what we are going to do is load these images, okay, and then classify them into one of these classes, one of these 7 classes in the next video. Okay, now let's jump into the actual part of this video where we see how to load this. Okay, now there are many ways. I'm just going to show you 2 ways. Again, part of this is inspired by me going through a bunch of code that's out there on Kaggle and everywhere else, and then I'm digesting it and regurgitating it for you guys. Okay, so first of all, again, at a high level, what am I trying to do here? Like I said, take the image file name, image name, read it, and place it into a Pandas data frame. That's one way of doing it. This requires a lot of RAM because now we are going to load all 10,000 into our Pandas data frame. The other method is using image data generator. If you're a Keras person, and if you're a PyCharm person, you probably should know PyCharm. If you are a I'm going blank in my mind. If you are a PyTorch person, then you can actually use the PyTorch's image folder, which is very similar to Keras's flow from directory, right? I mean, image data generator, which is, it just looks at your folder structure and assigns the class label as the folder name. So if that's the case, then you need to organize your folders such a way that that subdirectories have these folder names. If that doesn't make any sense, let's get to the point here. Okay, step number 1, method number 1. First of all, let's go ahead and import the libraries that we need. Nothing to explain here. Matplotlib for plotting, NumPy, Pandas, OS, Glob, and Pill to read images. So you should be familiar with all of these by now. Then our metadata file, I'm calling this skin data frame, okay, is this HAM10000 metadata.csv, correct? Let me make sure that's the right way. Yeah, that one, which is in HAM10000 dataset. So we are going to use Pandas to load that, and I've already done that. So my skin DF, when I open it, you should see, you should see that, okay, I have lesion ID, image ID. This is DX is what is it classified as, or label. If you want, you can rename this as label. And DX type, is this from histo, or is this from consensus? Where is it? If I go down, yeah, there is consensus. Oh, I keep scrolling through it. There is consensus right here. What process was used? Okay, and age, sex, and localization. Right. So this is the stuff that we already know. So as soon as you load your data, that's what you're going to see. Now, to this data frame, let's go ahead and add our images. This is the plan. How do you do that? First of all, let's go ahead and there's a reason why we imported OS. So now let's go ahead and split our text right here. And all we are trying to do here is basically look at this subdirectory and look at all the JPEG files. So this entire thing, you can actually get rid of that if you copy these images into one single folder, and then just look for all JPEG files. Okay. The reason why we have this line is to basically, hey, go to this directory. First of all, get to the directory subdirectory names, and then go to the first one, and then go to the second one, and look at all the JPEG images. Okay. So that's what my image path is. So if I go to image path, right here. So my image path is this, data slash HAM10000, right? HAM10000 slash, now it's looking for, where is it? Is it in part 1 or part 2? And what is the file name? That's exactly what this part of the code is doing. So once we have the path, we can just go ahead and read it, right? So that's exactly what we are going to do here. So once we have this path, okay, first of all, this line is adding that path to the data frame. So if I open the data frame again, okay, so the next thing is we are going to add this path to this data frame. Okay, you don't need to do that, but let's go ahead and add it, because it makes it easy for us to go do the next step, which is once you have that, okay, use that path, okay, to read the image. And how do you do that? I mean, again, watch my video on lambda functions. So now I'm using lambda function, which is, again, instead of writing a for loop, you can just do this in one line, right? I mean, that's what a lambda function is here. So for every x, go ahead and open this image, right? Open this image, resize it to 32 by 32. I can do this because I'm using my, my pillow library right here to open this image. You can do exactly the same using OpenCV or scikit image if you want to load it that way. But in this case, because resizing is easy with this pillow in a single line, this is exactly what I'm trying to do. Image.open, so you're opening the image and then resize it to 32 by 32 and then convert that into a NumPy array. That's it, right? That's exactly what we are doing for each x in this path. So for each of this image path, it opens this image and converts that into NumPy array and add that as a separate column in my SkinDF Pandas data frame. And the column name is image. That's exactly what this line is, okay? So if I open my SkinDF, again, this part, if once you run this, it takes almost, on my system, it took almost 5 minutes to load the entire thing. And you need at least 32 GB of RAM. I didn't try this on 16 GB, maybe try it out. But you need pretty high amount of RAM. If you don't have that, if you're just working on 8 GB or much smaller RAM, probably the next method that I'm going to show you is the best one for you. Okay, so let me scroll all the way to the right. In fact, let's make this a bit bigger so you can see my image right there. And each of this image, it's not showing what's in there, but there you go. Now you can see all the numbers in there. Okay, so this is my image. It's already a NumPy array, and it's going to be of the shape, let's not edit anything. It's going to be of the shape 32 by 32. Okay, so that is, in fact, let's go ahead and confirm that. So once you have this, now let's go ahead and see how many different types of images we have, or how many different types of DX do we have, or IDs do we have, right? So let's go ahead and plot it. So label NV, whatever that NV stands for. Let's see, Melanocytic nevi. Okay, so 6,700 of these, and then 1,000 of each of these melanoma, I think, MEL, and then this BKL. The rest of these are 500, 300, 142, and 115. This is heavily imbalanced data set. So if you don't do much of anything, there's a good chance that you may get high accuracy, but most of the images that are being classified as high accurate are, you'll end up with NV, label NV, right? So you have to do something to balance this, whether you add weights during training, or you kind of do the balancing beforehand by downscaling the number of images of NV or upscaling the number of DF images, okay? Okay, so far so good. Now I hope, again, if you want, you can go ahead and print them or show these images on the screen. So let's pick 5 by 5. So here you have these images up here, and if you zoom in, there is like a label up here. I should change the figure size so you can read them, but hopefully you can read them right there. Okay. Okay, so after about 13 to 14 minutes, what did we learn? Well, there are 7 different classes, and the images are in 2 different folders, and there is a metadata file. And we are basically extracting the path of each image by walking through these folders and each image and capturing that into a data frame, and using that path and applying a lambda function to each of those entries and loading the image and adding that as a separate column. to your data frame. I like this approach because everything is at one place. Now I have all the images, everything loaded into one data frame. The reason I dislike this approach is now you're loading tens of thousands of images into your RAM. It may not leave much room to do other stuff if you are limited by RAM. Okay, if that's the case, let's go to this next step. What do? Okay, this is the second method now. Okay, so let's clear the screen. The second one is it's a great trick to actually do even if you have if you're working with other types of data sets. First, I'd like to sort images into respective subfolders. What if you can go to each of these like BKLs and NVs and melanoma and all of these 7 classes and create 7 subfolders and extract the images that belong to each of this subfolder and dump them there. Okay, that's exactly what we're trying to do here. So in fact, the first step here, this one, is sorting these images into these subfolders. So what I did for that is I actually dumped all these images into single folder, first of all, okay, called all images. So if I go to all images, you should see 10,015 of these images in this folder. Now, I mean, I could have written similar lines as before, but it's easier this way. So now I have all images in one folder, which is my data directory. And then my destination directory is data/reorganized. So I went back, yeah, right there, reorganized. This is my destination directory. So take images from all images, put them in destination directory into respective subfolders based on the class names. So how do we do that again? So first of all, we are reading our metadata again, right? We are reading the metadata, and then basically, let's get to the meat of it. Down here, what we are trying to do is, first of all, make a directory, right? For I in label, what is my label? Let's run a couple of lines so it makes it easy for you. Okay, so let's do these lines. I really do not want to run this entire thing because it takes a lot of time. So let's do the relevant parts. Okay, there you go. And now let's go ahead and read this and print our counts. We saw this last time, right? I mean, to print this out, you don't need to load images. We just need to load metadata to see the distribution of data. And then now go ahead and look at these unique values and save it to a list. All I'm trying to do is extract the label names NV, MEL, and BKL into a separate list. So if you look at label images, there you go. So this is the list I just created. Now, in that label, right, the label that we just created, the list of labels, go through each one of those, okay, and make a directory with that name. Make a subdirectory with that name. That's exactly what it did. Make a subdirectory with the name of that label. Next, while you're there, go ahead and look at the image ID, okay, and if that label is equal to, for example, BKL or NV, if that label is equal to NV, okay, go ahead and find that image and move it. This is my input directory and this is the destination directory, and that's pretty much it. So I did that and it sorted all my images into, for example, AKEIC. I have 327 items, right? So let's move this. So AKIEC 327, okay? And if I go to a different folder, where is it? BCC. I have 514, BCC 514. So this is an easy way of sorting images and placing them into right bins. Now it's very easy to use, for example, Keras DataGen. Let's run this. Let's actually run this. Let's delete everything and start with a clean slate. Sorry for making this video long, but I want to make sure you understand this. I'll share the code anyway. Okay, let's run these libraries. I mean, these are pretty straightforward, right? So we are going to use image data generator to typically we use this to augment data, okay, which we are still doing it. But image data generator, we can actually supply any parameters within the data gen right here. Again, watch my video on data augmentation using Keras, but here you can say, okay, rotate the image by random rotation between 0 to 30 degrees. Random zoom, random, something. So you can perform different operations to your images. Right now, I'm not giving anything right there. Okay, right now I'm just leaving it blank. Okay, so let's go ahead and define our DataGen object. right there. So it created this object. Now, what do we do with that object, right? So first of all, where is my training directory? I added this line because it looks at my current working directory and then adds this to that current working directory. Okay, so let's go ahead and do that. My training directory. Okay, so if you just do, oh, sorry, where did I type? Oh, I'll remove that in a second. Train underscore ID. Oh, sorry, dir. So this is my training directory. Okay, reorganized. And what do we do with our training directory? Okay, the next step is train. I'm creating a flow from directory. Again, once you create your data gen, this is how you apply data augmentation, right? You create an object for data gen and you apply that object to your data. And the data can come from .flow or flow from directory. In this example, since it's coming from a directory, we have to tell it where the directory is. So datagen.flow from directory, the directory is my training directory, which we just created. Again, I apologize if this is too basic, but if you have never done this, this can be very helpful. Okay, the class mode is categorical because we have multi-class. Okay, if it's only binary, the class mode would be binary. So we have categorical, and batch size is 16, meaning each time while the training is happening, each batch, it's actually loading 16 images. Okay, and what exactly does it do? It looks at your training directory, loads some of these, like in this case, 16 images, and it performs any augmentation that you would do here, right? Image data generator, it tells, okay, rotate this image randomly, flip this image, or in a vertical or a horizontal way, and all that stuff. Right now, we're not doing any of that, but that's exactly what it does. So it loads 16 of this, and then target size is 32 by 32. If the images are all of different sizes, this is very useful. Also, if you cannot handle large images based on your RAM, just give what the target size is. Okay, remember, previously, I changed the size while reading the file. Okay. Again, let's go back. I'm resizing it while I was reading this and then capturing it as NumPy array. This time, I'm basically saying, hey, image data generator, okay, go ahead and resize them to 32 by 32. That's exactly what's going on here. Okay, so let us go ahead and run this line. Okay, so it says it found 10,015 images belonging to 7 classes. That's excellent because we know that's exactly what it's supposed to be. Okay, you're done. Now you can go ahead and work in Keras, for example. Now, if you want to just look at, okay, let's load a first random batch of 16. So let's go ahead and do XY next train data Keras. Now, if you look at up here, my X is 16 images, each image 32 by 32 by 3. And my Y is 16 images with 7 different classes. This is excellent, right? And you see, we aren't even converting this into categorical and everything because we already said, hey, this is class mode is categorical, so it should, if I'm right, convert this into one hot encoded array. Okay, so as you can see, the first one belongs to class number 5. The second one belongs to class number 5, and then class number 2, and so on. So it saves you a lot of time in not doing these steps that we typically do when we load the data into, a Pandas data frame and all that stuff. Okay, so let's go ahead and plot them since we loaded them. So what am I doing here? Oh yeah, I'm plotting each image. There you go. 1, 2, 3, 4. They all look different, as you can see. So it's just loading these 16 in this batch. Okay, so this is with Keras. I'll just quickly show you PyTorch if you're PyTorch people. Exactly the same thing. We are getting the directory in PyTorch. Again, instead of image data generator with a bunch of operations, you have equivalent transforms.compose. Okay, in this example, I'm resizing them to 256. Well, you can change this to 32, right? So that's exactly what we did before. Random horizontal flips, you can do, convert to a tensor, so you can actually bring it into your PyTorch model training later on. And if you want, you can normalize this. If these images are not normalized, that's another thing. You can also normalize these here, right? In image data generator, you can say 1/255. So you can scale them to values between 0 to 1. Here, you can normalize them with a mean around here and standard deviation around here for these 3. And then you can go ahead and train your, use your image folder, very similar to what we have done here, like datagen.flow from directory. You're doing exactly the same thing, image folder, and you provide your folder path. Okay. In fact, if you are providing your transform image, you obviously do comma your transform. I think I included that here. Yeah, the transform operation. I think that's pretty much it. So if you really would like to check this, how this thing works, let's go ahead and run it. Again, a sanity check. This is already a long video, but I hope you find this to be very useful. Okay, so it loaded, and let's go ahead and print the number of train samples there. Number of train samples 10,015. We know that, right? And the detected classes are, these are the classes. BCC is given a value of 1, BKL is given a value of 2, and so on. That's pretty much it. And anyway, let's go ahead and do some of these print operations. So you get a, we are not, let's not worry about this. Sorry, I keep doing these. I said let's not worry about it, but it bugs me if I leave it there. Okay, so as you can see, we have about 6,705 images that belong to class 5, and we know what that is, right? Class 5 NV, 5 of these. So we know that the data has been loaded successfully. Okay, that's a long video. I apologize, but I hope you find this to be useful, like I already mentioned. So let me summarize this by not extending it too much. 2 primary ways. One, go ahead and load them directly to RAM into your Pandas data frame. And 2, organize them into subdirectories first, and then use Keras or PyTorch to use your image data use your datagen in Keras, and in PyTorch use your datasets.image folder to kind of read the folder structure and automatically sort the data for you. So stay tuned, and again, wait for the next video where we'll continue this discussion and just do the classification part. That's the easy part. Handling the data is the tough part, by the way. Okay, I know you enjoyed this because after 25 minutes you're still here, so please go ahead and subscribe to this channel and you'll find more such content in future. Thank you very much.